we will discuss graph traversal methods. Traversing a graph means visiting every node of a graph exactly once. There are two methods. First one is depth first search, which is implemented using stack, and the second method is breadth first search, which is implemented using queue. Now we will discuss an example to understand how this is going to work. Consider this particular graph. There are totally 6 nodes A, B, C, D, E, F, how it has been connected. Now we will implement depth first search algorithm on this particular graph. So as algorithm says, any arbitrary vertex can be visited first. And each time when we visit a vertex, it has to be pushed into the stack. So let me start with the vertex A. And I will mark it as 1, indicating that A is the first vertex being visited, or you can say A is the first vertex which is entering into or pushed into the stack. Then we need to take any of the vertex which is connected to A, like either C or B. I can take these two. Any one of these I can take. Let me take C. So C is now pushed into the stack, or you can say that C is being visited. Now after C, we have to take any of the vertex which is connected to C. So now I have three options, E, F and D. Out of this I can use any one. So let me take, say, E. E is the third vertex being visited. Now for E, the connected vertex is F. So I have to visit F only, no other option. So I will be visiting F and pushing it into the stack. Now you can just observe, F do not have any other unvisited vertex which is connected to it. So you can say that F became dead end. Means it has to be popped out of the stack. So I am marking it as 1, which is the second index is marked as 1, indicating F is being removed from the stack. Now top of the stack will be obviously now E. So let us check whether E has any other unvisited vertex. No. So this will also has to be removed from the stack. So I am marking it as 2. Now C is the top of the stack. So we have to consider any other vertex being connected to C. Yes, we have D. So I will be writing D here as 5th vertex being visited. Just note down, I am writing D in front of E, indicating that after removal of F and E, now top of the stack is at this position. That is why it is D is written over E. That is, we should understand implicitly. That is why D has to be written parallel to E. Then D is the 5th vertex. Now D has one more vertex which is being connected to D, which is B. So now B do not have any more vertices connected to it. So this will become dead end. So before that, let me say 6th vertex being visited. Then after that, this is going to become dead end. So can you say that this is the 3rd vertex popped out of the stack? Then this will be again dead end. So 4th vertex being popped out of the stack, and this will be 5th vertex now, and this will be 6th vertex. So now the order A, C, E, F, D and B. This is your DFS order. Now for this DFS, you can construct a DFS tree. So how can I do that? So let me write here, A is the first vertex being connected. From there I have gone to C. From there I have gone to E. From there it is F. And from C we have taken D. And from D we have taken B. And note down the graph. You have B and A being connected, so mark it with a dotted line like this. Then you have CD is over, CE over, but C and F also have been connected like this. You can do like this. So now this tree is called as DFS tree. And these straight lines are called as tree edges. and dotted lines are called as back edges. DFS Traversal has many solutions. Means a same graph can be traversed in different ways using DFS. So to illustrate this one, I will take the same graph once again. Let me start with A. A is the first vertex being visited. Then from A, now I will go to B. Just to try to recollect, in the previous illustration, I have taken C. That means from A, I had two options, either C or B, and I have taken C. Now I will take B. So B is the second vertex being visited. Now from B, I have only one vertex to be visited, that is D. Then from D, I can go to C. Then from C, again I have two options, either E or F. So let me take F, fifth vertex, then finally E, sixth vertex. Now E becomes a dead end, no more vertices are there, so first vertex to be removed from the stack, then on top of the stack will be F, and F will be now removed because it do not have any other vertices connected to it, second vertex being deleted. Continuing in this manner, we will get C is the third vertex being deleted, D fourth vertex deleted, fifth vertex deleted, and sixth vertex deleted. So now A, B, D, C, F and E are going to be traced for this particular DFS. Now if I draw the tree for this one, it will be something like starting with A, then to B, from there I had gone to D, then to C, then to F, then to E. C and E has been connected, and A and C has been connected by back edge, because as per the graph these two vertices have been connected. So this is your DFS tree. So you can note down that a single graph can be traversed in different ways. In the earlier example, our answer was A, C, E, F, D and B. Now we have got A, B, D, C, F, E. Not only two options, there are multiple other options, because the algorithm of DFS itself says that the starting vertex can be any vertex of your choice. So in these two examples, I have started with A. Now let me take some other vertex as a starting vertex. Say let me take D, first vertex to be visited. From D, I can go to C, second vertex. From C, I can go to say E. I can go to then F. Now F will become dead end because it do not have any other vertex connected to it. So dead end. Then E will be dead end. But C has another option which is D. So D has to be written parallel to E. So fifth vertex. Then from D I can go to B, sixth vertex. Now this will be dead end. So third vertex to be removed, fourth vertex to be removed, fifth to be removed, and sixth to be removed. So D, C, E, F, D. Now F, this should have been A, not B, A. So D, C, E, F, A and B will be new trees. Like this, we can have many other traversal traces you can get for the same graph. DFS can be applied on directed graph as well. Consider this example. Here is a directed graph containing 5 vertices. So now let me start DFS traversal. Let me start with vertex A, first vertex being visited. Now from A, I can go to either A, B or C. Let me take B, second vertex to be visited. From B, I can go to only E, because outgoing edge from B to E is there, but D, though it seems to be connected, but there is no outgoing edge from B to D, but it is D to B. That is why connected vertex for B would be E, but not D. Hence, I have to visit E. Now, E becomes a dead end because it do not have any other outgoing edge. So, this will be marked as first vertex to be deleted. Now, B will be top of the stack. So, again B do not have any outgoing edge. Hence, this will be removed from the stack. Now, I have top of the stack as A. So A has one more vertex which can be traced, which is C. So I will be writing this in front of B, fourth vertex to be visited. Now again, C is a dead end because it do not have any outgoing edge. Now we can just observe. We will come back to A because A also do not have any other outgoing edge. So this will be fourth vertex to be deleted. We can see that now A, B, E and C all have been removed from the stack. That is, stack is empty. But still there is one unvisited vertex which is D. In that sense, we can start with that unvisited vertex again from the beginning. So on the stack D will be inserted. So fifth vertex to be visited. So you just can note down, I am writing D just in front of A, and earlier C has been written just in front of B. So whenever we write numbers or the elements parallelly, which indicates top of the stack. Now D is the fifth vertex to be visited, and it do not have any other unvisited vertex, so it has to be removed from the stack. So now DFS traversal would be A, B, E, C and D. For this, we can generate a DFS tree something like this. A is the first one to be visited, from there B, and from there E. And from B, we had C, so this has to be marked something like this. And from A, we had D. So now from D to E, there was an edge which can be marked as a back edge, something like this, and D to B also we had an edge like this. So this will be DFS tree. So traversal of directed graph using DFS will be helpful in solving topological ordering problem.